Welcome to STAR OMOP Tutorials. My name is Tutorial3Part1-OHDSI and I'm the Research and Development Manager for Biomedical Informatics here at Research IT at Stanford Medicine. This is part 1 of Tutorial 3. This tutorial is primarily going to be focused on helping you get familiar with ATLAS. ATLAS is really a free, publicly available web-based tool that was developed by the OHDSI community, and it really facilitates cohort generation and execution of analysis on data which is available in the OMOP Common Data Model. So it's both a cohort generation tool as well as an analysis tool. So the way we're trying to set up this particular tutorial is we're really trying to leverage the fact that the OHDSI community has already put on YouTube a whole bunch of ATLAS tutorials. So what we're going to do is we will walk you through what is specific and special about the Stanford instance. But for the main functionality, what we've done is added the OHDSI ATLAS tutorials to this, to the playlist. So I really would urge you to look at those ATLAS tutorials. They walk you through, different functions of ATLAS, as well as the best ways, examples of how to generate a cohort and so on. We do have some tips and tricks on how you can actually, get a cohort definition from, say, a colleague or from the public ATLAS site. And we will walk you through all of those. So we have videos for just those specific things. So it's really, we hope you use both the resources, the recordings that we have done, as well as the recordings that have been done, by the OHDSI community. So in general, the outline is, we're going to walk you through some of the OHDSI tools, ATLAS, the Stanford ATLAS, the ATLAS paradigm, just so you get like a 30,000-foot view of what is the primary motivation and how ATLAS works. And then I have here a list of the resources. One thing that's really special about the Stanford ATLAS is the fact that we have actually enabled the execution engine, so you can actually run analysis. And it's basically paper ready, your analysis, right from cohort generation to actually doing a population level estimation or a patient level prediction study. So we will have examples of those, but the others, I really encourage you to also watch the OHDSI tutorials. Here are some other resources. So the book of OHDSI actually talks a lot about, how do you generate a cohort. The definition of a cohort is different in the OHDSI community than it is in, as understood in many other parts. So I really encourage you to actually read that chapter as well, and pay special attention to how exactly it is that they define a cohort. All right, so let's get started. So yeah, ATLAS is basically a free, publicly available web-based tool. And it actually supports various data analytics use cases for observational patient level data. So, but this patient level data has to be available in the OMOP CDM. There is a public ATLAS. So what they have done in the public ATLAS, and I will give you the URLs for all of those. Oh, it's right here, the ATLAS demo.ohdsi.org. The public ATLAS, they have just uploaded the SynPuff data, and anybody can actually go in there and create cohorts that they can then share with the rest of the community. But each site runs their own ATLAS. So for example, for this tutorial, you will need to get access to the Stanford ATLAS, and the Stanford ATLAS does have the STAR OMOP DID Lite dataset at the back end. It has the STAR OMOP DID Lite dataset because ATLAS does not have any place to actually reflect or expose the clinical notes or any of the unstructured data. So it's basically, it's a GUI for just the structured data. You could really explore the structured data part of the STAR OMOP DID light data set. So that is the link for the Stanford instance. This is the link for the public instance. So let's just take a second and maybe just go there. I'll just show that to you. It takes a couple of seconds to load. The OHDSI ATLAS tutorials are, the backend for them, or the example for them. They're actually using this public Atlas version. So this is the public Atlas. If you actually click here on data sources, it basically has the SynPuff data set. It has 1,000 patients and 5% of the data set, and this is what the OHDSI tutorials, basically show you examples from here. Coming back to the Stanford Atlas, you should be able to go to this link, and it walks you through the steps you need to take to get access to the Stanford Atlas. You will have to get in touch with me, but I need you to sign the DPA and so on before we can do that. This is the URL for the Stanford instance. And let's actually go ahead and go to the Stanford instance. So I want to show you some things that may be specific to the Stanford instance, but at this point you can actually go off, watch all the OHDSI Atlas tutorials, and then come back and join us back here. So this is the Stanford Atlas. It will take a couple of seconds to load. If you actually, once you have access, if you click on data sources, you click on this drop down menu, you're going to see a bunch of data sources. So we actually have the Optum data. This is the Optum DoD data in OMOP format. We have this STAR DID light data set, both the 1% and the full DID light data set. Right now, depending on when you actually look at these tutorials, you may see both the BigQuery version and a Postgres version. We're actually testing these out, and we're hoping that we can actually just stick to the BigQuery version because that's where our data lives. And then the SynPuff data set. So once you, when you try to get access for the STAR DID light data set, you will be able to use any of the STAR DID light data sets as well as the SynPuff data set. The Optum data sets are actually, they are owned by PHS, and you would need to have access, your access enabled from PHS before we can give you access to the Optum data set on Atlas. All right, so let's just for our example purposes, let's actually go, I'm just gonna hit Postgres or BigQuery, both should be equivalent. That's the data source I'm going to use. You can go and click report, and this is really like a summary statistics of the OMOP DID light data set. So let's go ahead and, if you hit dashboard, you see the number of persons in the STAR DID light data set is about 3.1 million at this point. The gender, the distribution by gender is, we have about 1.67 female patients and about 1.42 male patients. This is the age at first observation. So you can see that there is this big spike here, which basically is all our LPCH data. So these are all the new babies that are being born. And then this is essentially how many people, how many people we have of that age group. The cumulative observation is actually a really interesting chart. It actually tells you what percentage of the population in the data set do we have that many years of data for. So for example, for 66% of the population, we have about half a year worth of data. But for 31% of the population, we have 5.8 years worth of data. For 5% of the population, we have 17 years worth of data. And then the persons with continuous observation by month. This chart actually can tell you how many patients do we have that were observed in that specific month. So if you actually, hover over the chart, so for the month of January 2012, we had, 700K patients data continuously observed in that month. This spike that you see, this is actually, this is an artificial spike. This corresponds to the fact that this is the time around which we actually uploaded a whole bunch of data from the old CDM or from the old EMR to Epic. So this spike actually basically corresponds to when we transferred all our records to Epic. Going down data dashboard, if you click on data density, this is really just telling you the density of data that we have for each of the clinical tables. So if you look at this list here, this list in the legend, this is nothing but your clinical tables, your standard clinical tables, right? Your procedure occurrence, your condition occurrence, and so on. And this is just giving you a sense of what is the density of data that we have for each of these clinical tables. This is the records per person. So as you can see, it's actually the observations and drug exposure is what we have the most records for. But this is basically just giving you a distribution of how many records per person we have. And then these are just box plots. As you can see, like the condition occurrence, we actually have a patient for whom we have 511 conditions, but for most patients, that's where our median is about 6. That's the box plot for condition occurrence. That's the box plot for drug exposure. This is the drug era, the procedure occurrence, condition era, and observation table. This is basically just more details about the person table. So this plot here actually shows you how many persons do we have in our database who, so it's with respect to their year of birth, who were born in that particular year. So you can see we have most of our population is between people born between 1947 and 2014. This is again the gender distribution. This should be identical to what you saw before in the first, the overview dashboard. And then this is people in this cohort stratified by race. So this is just a pie chart showing the race distribution and the ethnicity distribution. I urge you to go through all of these. The OHDSI tutorials also walk you through each of each section of this report, as well as all of this functionality, and gives you a sense of how to actually use this. So just for fun, let's actually look at the condition occurrence table. So you can actually look at it either as a tree map or as a table. So let's go ahead and look at it as a table. So this is actually telling us this is sorted by person count. So the condition that we have the most number of people for, the most number of records for, is this generic condition called illness, but then it's hypertension, hyperlipidemia, cough, and so on. You can also resort this by prevalence. So that's by prevalence, but if you resort it by records per person, you can see that the condition mucopolysaccharidosis is the condition for which we actually seem to have the maximum records per person. So you could actually sort this whichever way you like. Either look at the tree map if that's more helpful. The darker the color gives you a better sense of the density. The box size is pertains to prevalence, and the color is the records per person. So light to dark. Dark means it's, you know, you have a higher number of records per person. All right. The other thing that I did want to quickly mention, as I'm going back to the first slide, is the three kinds of analysis that Atlas allows you to do: characterization, population level estimation, patient level prediction. These are what are really special about the Stanford ATLAS. So you can see these down here. This is the population level estimation, and the population level estimation and patient level prediction, and these incident rates. So we have our Stanford execution engine turned on, so you can actually run this analysis on this instance itself. And these are just examples of how you would run population level estimation studies or prediction, patient level prediction studies. And we actually have separate videos that really walk you through how we do that. The really cool thing, I think we mentioned this before, about the OHDSI consortium is that it's extremely interactive. The community on GitHub is really active. So if you have any questions, of course, shoot us an email or, you know, send us a Slack, but feel free. We really urge you to participate, you know, on the online community. There are new tools that are being, you know, that are being created by people. It's an open source consortium that you can actually use along with Atlas to really help you do both your cohort generation, your data exploration, and your analysis. So before we close for this video, just a quick question for you guys. So I hope you've taken a few minutes to actually go through the Atlas search functionality. You know, let me actually go and show you what that looks like. So essentially it's just a text box and you can type in anything there. So it could be any of your concepts, it could be a condition you're searching for, it could be a drug type. So let's go with, I'm gonna just go with hypertension. And what you will see is this is actually also like a GUI, a visual representation of essentially your concept table. So your concept table, your concept relationship table, and your concept ancestry table, you can explore that either via SQL or via Athena or via Atlas. So the main thing to remember is that this is Stanford's Atlas, so the vocabulary that we have uploaded here is indeed exactly the vocabulary that is used for creating your star OMOP DID Lite. If you go to Athena, if the vocabulary has been updated by OMOP or the OHDSI consortium, but we at Stanford have not, you know, upgraded our vocabulary. And usually the changes between the vocabulary versions are really incremental. But if we have not upgraded our vocabulary, that change will not be reflected in our OMOP. So, but if you actually come and explore, use Atlas to actually explore your concepts, this is exactly what your, you know, the current data set, the star OMOP DID Lite, is using this vocabulary, the vocabulary that's reflected here. And as you must have realized, our data sources, we update our Stanford star DID Lite every week, and correspondingly the Atlas is also updated every week. So you're always looking at fairly current data, not more than a week old. So you can see here, I just put in hypertension as the search term. I got, you know, 119 pages worth of hits. But you can see I actually have this. This looks really similar to the Athena interface, as in I can select or filter by vocabulary, I can filter by class, I can filter by domain, I can filter by standard and non-standard concepts. So I can go standard concepts and now see for conditions. Remember, they are all going to be SNOMED. Here is essential hypertension, benign hypertension. These are probably all related somehow in their hierarchy. So actually, let's just go ahead and click one. And here you can see that's the concept name. The source vocabulary is SNOMED. This concept ID, this is the concept ID, and it's a standard concept. You can see what are the related concepts. So you can even see what are the related concepts in different vocabularies. And here this actually shows you the hierarchy. So essential hypertension is the concept that we're exploring. Its parent is hypertensive disorder. And then all of these benign hypertension, malignant, essential hypertension, these are all the children. And you actually go in here, you can look at the record counts. Actually, if you just, let's just go here. So this gives you just a sense of the record counts for essential hypertension in each of these databases. So depending on whether or not you have access to Optum, you may not see these record counts, but essentially you should see them for everything else. All right, so before we close, just a quick question. Using the search functionality, you can find the standard concept ID of a condition, query the CDM's entire concept table, find the ICD-9 code for hypertension, all of the above, none of the above. So take a couple of minutes and think about what you think the answer should be. And then for those of you who said all of the above, that is correct. So ATLAS is really, it's another GUI for your concept table, concept relationship, and concept ancestor table. So you can explore your concepts, really explore your vocabulary in ATLAS. And you need that as you are building up your cohorts, but we'll talk more about that in the next tutorials. All right, thank you.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.